Okay, so the block is sliding to the left, but it's decelerating at 3.12. Okay, so it's sliding to the left, but it's sliding to the left slower and slower and slower. It's slowing down. This makes a difference. Okay, so let's let's draw pictures of these. These are all the possible scenarios, right? Here's the scenario that we're talking about in this problem. Okay, it's sliding to the left but decelerating, right? Well, if it's sliding to the left and decelerating, doesn't that mean the acceleration is this way, right? So if it's sliding to the left and going slower and slower, right, then the acceleration is opposite the direction it's sliding. So the acceleration would be to the right or positive. Okay, let's draw another picture here. Okay, let's suppose it's sliding to the left and accelerating in the conventional sense, as in going faster and faster, right? Okay, well, then the acceleration must be this way, right? The acceleration is negative, okay? Because when the acceleration is in the same direction that it's moving, right, then it goes faster and faster. If the acceleration is opposite the direction it's moving, so here the velocity is this way, right? Okay, here the velocity is this way, right? Okay, but the acceleration is to the right. So if the velocity and the acceleration are in opposite directions, right, then it decelerates. If the velocity and the acceleration are in the same direction, then it's accelerating. It's going faster and faster. Here it's going slower. Okay. Now let's draw the other scenarios, right? Because this is the only hard part about this one, right? Okay. Let's suppose in the other case, right, that you are sliding to the right. Okay. But what if we're sliding to the right and decelerating? That is, in a few moments we'll be stopped. Okay. Well, our velocity is to the right. Here's our velocity, right? But our acceleration is to the left. Okay. This is decelerating. So we're sliding to the right and all the net force is acting to the left and slowing us down. Okay. So this would be a negative acceleration because the acceleration and the velocity are in opposite directions and we're going slower and slower, right? We're slowing. Okay. And then let's draw the other scenario, right? Is that, let's say we're sliding to the right, but we're accelerating. And by that I mean going faster. Okay. In this case, the acceleration would be this way, right? The velocity would be this way to the right, and the acceleration would be to the right. This would be a positive acceleration. So in this problem, this is the key thing, right? Sliding to the left, but decelerating. Okay. What does that mean? It means that our acceleration is positive, simply put, right? So let's just go back to the simple problem here. We are sliding to the left, okay, but we're decelerating. So our velocity is that way, right? If we're decelerating, then our acceleration is positive 3.12, okay? Velocity is negative, but the acceleration is positive. This will make a difference, right? Now, there's some unknown force acting on the block, and so we'll just draw that in here, as we don't know where it is, right? Okay, and then since it's sliding to the left, the friction force would be to the right. So we'll draw a picture of this guy here. And we figured this out in problem part 0 of this formative assessment, right? Okay, so we've got unknown force. We've got a force that's definitely to the right because we're sliding to the left. Okay, this guy is to the right. And then we have an acceleration that is to the right. So now we're set. We just set it up. We go force plus 4.998 equals 4.25 times positive 3.12. Okay, so this is sliding left, but decelerating. Okay, so if you're sliding to the left, but decelerating, the velocity is negative, but the acceleration is positive, right? Acceleration is positive. Okay, these guys are in opposite directions. That's why it's going slower and slower. Because it's sliding to the left, okay, That's why this guy is to the right. And then unknown forces, you always guess them to just put them in as an F, like that, right? And so now we're set. Basically, it's going to be this times this minus this, okay? So I go 4.25 times 3.12, and then I go minus 4.998, and I get 8.262. Okay, so that force is actually to the right. The force would actually be a bit bigger than that force, right? Okay, both these forces would be to the right, and that makes it decelerate at this rate. Presumably, without that force, it would decelerate more slowly than that. All right, hope that helps.